Hello friends, so here is another question on basic description of motion, the parameters associated with it. So it has been given a particle is moving along x-axis and at a particular time t1 equals to 2 seconds starting time, its position is at x1 is equal to 3 meters, and then another reading is taken at time instant t2 is equal to 7 seconds and its position at that time instant is x2 is equal to 18 meters. What is the average velocity of the particle? Okay, so this is the direction of motion of the particle along the x-axis. Okay, here this is the point where the study of the object, the movement of the particle started, and the time instant is t1 is equal to 2 seconds. This is the starting point. Okay, and this position is x1 is equal to 3 meters. Okay, then another reading was taken. Here the time instant is 7 seconds. Okay, and here the position of the particle is 18 meters. Okay, this is the start, this is the end. Now here average velocity, we all know average velocity. Okay, here it is moving along the x-axis only, so no change in direction, so the terms displacement and velocity will come. Average velocity is net displacement by time taken. As it is happening along x-axis, it will be delta x net displacement by total time taken for that displacement. Here delta x is 18 meters minus 3 meters, which is equal to 15 meters, and the time taken for that, it is the final time 7 seconds minus the initial time 2, that is equal to 5 seconds. Here it is xf minus xi, final position minus initial position. This is the initial position, this is the final position. Similarly here, this is the final time, this is the initial time. It is delta t is equal to tf minus ti. Here it is delta x. So here average velocity is delta x, which is equal to 15 meters, delta t is equal to 5 seconds. So here average velocity is simply equal to 3 meters per second. Okay, so this is the average velocity. We average 3 meters per second. Okay, so here is another question. It's a very simple question. It is given that a train is traveling east, in the east direction, at an average speed of 120 kilometers per hour. How far does this train travel in 6 seconds, or how much distance it covers in 6 seconds? So the only concept here to be utilized here is that the speed here is given in kilometers per hour. The only thing we have to do is to convert it into meters per second. So here 120 kilometers per hour, that is equal to 120 to 1000 to this much meter per second. 1000 meters and 1 hour is equal to 3600 seconds. All we have to do is that. This is equal to, if we calculate, it is coming around into 33.3 meters per second. This is the average speed. Time is given 6 seconds. So the distance covered in the 6 seconds duration is product of speed and time. That is 33.3 meters per second into 6 seconds, which is equal to, it is coming in 200 meters. Okay, very simple and straightforward question. Only thing which is important here is to convert the speed which is given in kilometers per hour into meter per second. Rest everything is simple, straightforward. Simple. Okay, this one. So friends, here is another question. So it has been given that a runner runs 100 meters in 10 seconds and then turns around and jogs 50 kilometers in the opposite direction in 30 seconds. We have to find the average speed and the average velocity for this entire journey. Okay, so let us try to visualize here. Let's say this is the starting point and we'll assume that the direction is x-axis. Okay, just for the sake of understanding here. So first, the runner, he runs 100 meters, let's say, towards this point. Okay, this is 100 meters. And the time he takes for that is 10 seconds. Okay, 100 meters, 10 seconds. Then he moves in the opposite direction. Moves in the opposite direction and reaches, let's say, here 50 meters in the midway position here at this point. Okay, this is 50 meters. So this is the final position. And this was the initial position. So deliberately it has been asked these two parameters, speed and velocity, to test our concepts related to it. So I've always told you that whenever the parameter speed will come, it means it is associated with distance, the total distance. And whenever we have velocity, it is associated with displacement. So here if we see, the total distance covered by the runner is first running 100 meters, then jogging 50 meters. Total distance 100 plus 50 meters is equal to 150 meters. Total time taken, running it is 10 seconds, jogging it is how much? 30 seconds. Total time 10 plus 30 seconds, which is 40 seconds. So average speed is total distance by total time. 150 meters by 40 seconds. So it is coming around 3.75 meters per second. This much. Okay. Then if we take velocity into consideration here, then we have to consider the net displacement. See, first the runner, he ran to this position 100 meters and then back in the opposite direction 50 meters. So if we take the net displacement between the initial and final position, it is only 50 meters. This is the net displacement. I have already explained in detail the difference between distance and displacement. But here the time taken to achieve this displacement is the same. Okay, that is 10 seconds plus 30 seconds equals to 40 seconds. So here net displacement is 50 meters and total time to achieve that displacement is 40 seconds. Even though the distance he has covered is 150 meters, but the displacement is 50 meters. So average velocity is equal to displacement by time, which is equal to 50 meters by 40 seconds, which is 1.25, I think. 50 divided by 40, yes, 1.25, yes, 1.25 meters per second. This is the average velocity. So average speed is this much. Okay, let's say speed average, this is velocity average. So always remember the concepts associated with speed and velocity. When speed is asked, you have to take into consideration the total distance covered, and when velocity is asked, you have to consider the net displacement from the initial position, the gap between initial and final position. The time taken for both to achieve the distance and displacement is the same here. Okay. Hello friends, so here is another question on basic parameters related to description of motion. So the question is that a particle moves along a circular path of radius capital R. It starts from A and moves in anti-clockwise direction. Calculate the distance and displacement from the various points are given B, C, D on this circular path, and we have been asked to calculate the distance and displacement from A to B, both distance and displacement, A to C, distance and displacement, A to D. Okay. So a few important things. Whenever you determine distance and displacement, there are two things that are important. First is the initial starting point. This is the initial position. Okay, this point A. Okay, and another important thing to remember is the radius capital R. Okay, this is the radius. Okay, now from A to B, from A to B, this much portion the particle it covers, which is basically 1/4 of the circumference of the circle. okay, which is the distance. First case from A to B, which is 1 by 4 into 2 pi r, okay, which is equal to pi r by 2. This is the distance from A to B. Now the particle, it reached this position. Now if we join, always remember I mentioned the difference between distance and displacement. Displacement is the shortest distance between the initial and final positions, the straight line path connecting these two points. Here AB straight line path is the displacement. So if we use Pythagoras theorem, AB is equal to root over of OA square plus OB square, which is equal to r square. OA is the radius, OB is the radius, it's the same, r square plus r square root over, equal to 2r square root over, which is equal to root 2 r. Okay, this is the displacement from A to B. This is the first case. Then is the second case from A to C. So from B it moves to C. So the total distance covered from A to C is 1/2 of the circumference, okay, A to C. So the distance here covered by the particle is 1/2 of the circumference, which is equal to 1/2 into 2 pi r, which is equal to pi r. Okay, this is the what? Distance covered. Distance from A to C. Next, displacement. The 2 points, this is the initial, this is the final position. The shortest straight line path covering these 2 points is this. This is the shortest straight line path. So displacement is equal to simply AC, the straight line path AC, which is nothing but twice of the radius, which is the diameter of the circle. That is the displacement from A to C. Then the third case, from C it moves to D, starting from A to B to C to D. So here the particle has covered almost 3/4, okay, 3/4 of the total circular path, the circumference. This is the first quarter, this is the second quarter, this is the third. Okay, 1 by 4 here, 2 by 4, which is 1 by 2, here it is 3 by 4. So here from A to D, third case, distance is equal to 3 by 4 of the circumference of the circle, which is equal to 3 by 4 into 2 pi r, which is equal to 1.5 pi r. That is the distance from A to D. And displacement, again always remember, this is the final position, this is the initial position. Displacement is always the shortest straight line path connecting the initial and final positions. Okay, so here displacement is equal to AD. Displacement is equal to AD. Again, Pythagoras theorem, it will be root over of OD square plus OA square. Displacement is equal to AD, which is equal to root over of OA square plus OD square. OA and OD, they are the radius r, equal to r square plus r square is equal to again root 2 r. That is the displacement. Okay, A to D, this. Okay, so very basic simple question, but involved a lot of good concepts here between the difference between distance and displacement. Okay,